Traditional computer mice require heavy usage of the fingers and hands, and for those with impairments, this can be very difficult or strenuous. We designed the Unidentified Flying Mouse to solve this problem. Using IR tracking and gesture controls with an accelerometer, the movement of the cursor is now decided with the arm instead. Putting on the UFM mouse is simple. The compression sleeve slides onto the forearm, and each enclosure sticks onto the sleeve using Velcro. Once the battery is plugged in, it's ready to pair with the computer using Bluetooth. The battery can be recharged using a USB Type-C cable. Pairing is the same as for any other Bluetooth device. Just go into the computer settings, select the mouse device, and pair. After placing the reference LED in a convenient location on the desk and turning it on, the mouse is ready to use. In this example, I move my arm to move my cursor over an application. Then I hold my cursor still for a moment and roll left to left click and open it. Here's how it works. We place a battery-powered infrared LED, which is not clearly visible to the human eye, on the desk. This is captured and tracked at 200 frames per second by the PAJ7025R3, designed by the current world-leading supplier in optical mouse sensor chips, Pixart Imaging. It's an integrated CMOS image sensor and processor that has object tracking capabilities. It tracks the LED with a 141-degree field of view and returns its coordinates as seen in the sensor using SPI protocol to our ESP32 microcontroller. The controller compares the positional values between frames, then remaps them according to the resolution of the computer screen to determine the amount of movement the cursor should have. UFM is made to be HID compliant, which means it can send mouse commands to a computer via Bluetooth right out of the box. Gestures for clicking are captured using the MPU 6050 IMU, which measures angular velocity and acceleration. These measurements are used to detect different gestures, such as rotation to left click as seen in the demo. A haptic motor has also been included to provide real-time feedback to the user to indicate a switch from the state that captures cursor movements with the IR sensor and the state that captures gestures with the IMU. A big challenge we ran into early on was communication with the Pixart IR sensor. It has a non-standard hardware interface and a strict 300°C temperature limit when soldering. This required us to design a custom PCB, or printed circuit board, and use extreme caution when soldering. Our experience in designing the first PCB also opened the door to making a second PCB to hold all the main components, which drastically reduced the size of our device. We were then able to order these through JLC PCB, a company that manufactures and ships custom printed circuit boards. We also used the Thode Makerspace workshop, which offers the use of their 3D printers and soldering equipment. Their hot plate station allowed us to solder SMD components, and their free 3D printing filament allowed us to perfect our enclosure design over multiple iterations at a minimal cost. At this stage of development, our prototype can successfully be used as a responsive mouse cursor and perform left and right clicks. Future plans will include gestures to click and drag, double click, and scroll. We believe our current hardware implementation is sufficient, and these goals could be achieved given more software development time.